Hey everybody, it's Mr. Roy here. I'm going to take you through a lesson on something called trigonometric ratios. So we're going to start just by considering how um, we've learned about similar triangles and how we compare them to one another. And then we're going to use that knowledge of similar triangles and extend it even further into this new area of trigonometry. So I've got some triangles here, and it turns out that all these triangles are similar triangles. And it turns out all these triangles actually have an angle right here that happens to be 30 degrees. And so although each triangle is of a different size, I happen to know that all the angles are equal. Now if that's 30, that means this other one over here has got to be 60. And of course our 90-degree angle is marked by that little box in the corner. So I say, okay, these three triangles all have the same angles. That means they are all similar to one another. And that makes it really easy to compare their sides. Now the sides on this first triangle happens to be 3, 4, and 5. On this triangle on the far right hand side, the sides happen to be 8, 6, and 10. And this huge triangle that's right in the middle happens to be 12, 9, and 15. So when you look at these, I'm sure you can probably notice that there is a scale factor between them. To go from our little triangle to our medium triangle, you'll notice that all the sides are multiplied by 2. To go from our little triangle to our biggest triangle, all the sides are multiplied by 3. So although all these triangles have different sizes, there is that relationship there between them. There's also another relationship, though, between each of these triangles, and that happens when we divide the sides. So I'm going to go through a little thing here where I'm going to do some division of the sides of the triangles and see what happens. So on my first little triangle here, what I'm going to do is I'm going to take the side that's on the right there, and the side that's on the bottom, the two legs of the triangle. So I'm going to ignore the hypotenuse for now. I'll take the two legs, and I'm going to divide them. So this is going to be 3 divided by 4. And I say, okay, 3 divided by 4, what does that work out to? That's actually 0.75. For this large triangle in the middle, I'm going to divide the same sides. I'm going to divide the one on the right by the bottom one here. So that's going to be 9 divided by 12. And from what you know about equivalent fractions, you probably know that, oh, that's actually the same. That's actually also 0.75. And for this triangle over here, if I divide those two same sides, I'm going to go 6 divided by 8, which is also 0.75. So although these triangles are completely different sizes, if we divide those same sides, we get the same number no matter what. Now why is that? Well, it's because of that scale factor. If one side gets proportionately bigger in a similar triangle, so does the other side. So even though the two sides might be bigger, when we divide them both, we end up with the same result. Let's take a look at a different one. Let's now take that side on the right there, and let's divide it by the hypotenuse. So in this case, I'm going to go, okay, let's go 3 divided by 5. Right? And we say, okay, well, that's going to work out to 0.6. And in this one, I've got 9 divided by 15. That's also going to work out to 0.6. And I've got 6 divided by 10. That's also 0.6. So again, no matter which triangle I'm looking at, because they're similar triangles and they have the same angle, we're going to get the same result, no matter how big that triangle is. Let's finish this off by doing the last comparison. Let's compare the one on the bottom with the hypotenuse. So in this case, it would be 4 over 5. That's 0.8. I bet you can guess what's going to happen over here. 12 divided by 15 works out to the exact same value, and 8 over 10 works out to the exact same value. So the fact that we know that with a different triangle, as long as the angles are the same and those triangles are similar, we're always going to get the same ratio when we divide two sides. So I'll say that again because it's an important idea. If we've got triangles that have the same angles, if we divide the same sides on those two triangles, even though the sides are different lengths completely, we end up with the same ratio. In this case, 0.75, 0.6, and 0.8. That's a key idea that's going to allow us to jump into our learning today. So let's get to the notes that you've got in front of you. And let's actually go through some of this and talk about trigonometric ratios. So we're going to use what we understand about similar triangles and the fact that they can contain the same angle. They would contain the same angles and have proportional sides. And we're going to use that to extend that to solve problems. Now we're going to be looking exclusively to start at triangles that have 90-degree angles in them. So we're calling them right triangles, and they have to have that 90-degree angle. As soon as you see a triangle with a 90-degree angle, you should go, aha, trigonometry, that's what I'm getting at. Okay, so these triangles, of course, have some relationships between their sides. Some of them you already know, like the Pythagorean theorem. We know that's a relationship between the sides of a 90-degree angle triangle. But there's actually 3 more relationships that we're going to introduce today, and these relationships are going to allow us to solve a whole variety of problems with right angle triangles. So before we go any further, the thing we have to do is we have to be able to label these triangles, okay? So right angle triangles can be labeled according to a specific angle. So the first thing we need to do is we need to choose an angle that we're looking from, and we need to decide that's the angle that we're going to label our sides based on. Okay? If you choose a different angle, you have to relabel your sides. So we're going to focus on one specific angle. Okay? So right down here I have a diagram, and I'm looking at an angle here. And this angle, we're going to use the most common symbol for an angle, and that's called theta. That's this symbol right here, theta. Okay, so we could use an X or a Y or whatever for that angle, but theta is the one that's by far the most common to indicate an angle. So you're going to see that showing up a lot. So this is the angle we're going to look from. Now when we're looking from this angle, we want to label our sides. The first one we're gonna label is our hypotenuse. The hypotenuse, we always know what it is. It's always the one that's across from. Let me change my ink here. The hypotenuse is always across from that 90-degree angle. So that's probably the easiest one to label, is that it's across from that 90-degree angle. The other sides here, the opposite one is opposite the angle that we're looking from. So I'm looking from this angle theta, so the side on the other side of the triangle that's not touching angle theta at all is called our opposite side. And that means our remaining one right here is our adjacent. Now adjacent is just a fancy word for next to, right? So this is actually next to our angle, and you'll see along with the hypotenuse, it's the side that makes our angle. Okay, so hypotenuse across from the 90, opposite is on the other side of the triangle, adjacent is right next to our angle. Now if I were to actually look from the other side of the triangle and use the angle theta over here, I would have to relabel my triangle. My hypotenuse would still be good. That's always going to be the hypotenuse. But my opposite and my adjacent would switch sides because I'm looking from the angle on the opposite side of the triangle. So the labels for our triangle all depend on the angle you're looking from. So determining which angle you're looking from is really important, is a key part of this. Okay, let's move on. Let's do a little bit of labeling with our triangles here. So I've got 2 different triangles, and I'm going to try and label these and make sure that these are nice and organized. The first one that's really easy to label is the hypotenuse. So I can grab my hypotenuse and I can drag it out and I can put it there. And I know it's there because it's across from my 90-degree angle, right? So nice and easy, I say, okay, that's my hypotenuse across from the 90-degree angle. The next one I've got is my opposite side. So I'm going to look at the angle I'm looking from. I'm going to draw an arrow across to the opposite side of the triangle. And then I'm going to drag that opposite one and say that's my opposite side. Finally, I've got my adjacent side. That's going to be the one that's right next to my angle. It's actually touching my angle. It's one of the sides that makes my angle. So that's the adjacent side. So I'll put my adjacent one right there. And we've properly labeled that triangle. Now, we could now have a look at this next one, and I can say, okay, maybe this time I want to, I don't know, get a little more creative here, and I'm going to label my opposite side first. Let's try that. So I'll go opposite, I'll drag out an opposite, and put it there because it's opposite the angle. Now, you might say to yourself next, which side is the adjacent one? Both of these sides are adjacent to my angle. So how do I know? Well, how you know is the hypotenuse is always the one that is across from the 90-degree angle. That's always the hypotenuse. And that's why I recommend labeling it first, because that'll make your life much easier. So the adjacent must be the remaining one that is still next to that angle. Okay, so labeling our triangles is our first key skill that we want to have for today. Okay, so let's talk about how we're going to add some numbers and things like that to compare these triangles together. So we've got our first triangle. We see it's got an angle of 30 degrees and it's got sides 6 and 8. Now I could use Pythagorean theorem, right? And I could say, okay, Pythagorean theorem is going to show me that these sides can give me the hypotenuse. So I can say, okay, the hypotenuse, we'll call it x. Oop, not x squared, that's going to be in my formula. We'll just call it x is the side I want to know. And now when I do the Pythagorean theorem, let's do the math. I'm going to say my hypotenuse squared is going to be equal to the other two sides squared. So that means my hypotenuse squared is 36 plus 64, that's going to be 100. So x is going to be the square root of 100, and that's going to be 10. So this side is going to be 10. Now I can look at these two triangles and say, aha, these are similar triangles. I can tell because they've got a 90-degree angle, they both have a 30-degree angle, and that must mean that this angle up here has got to be 60 degrees. All the angles are the same, and so these two triangles are similar. And I could compare these two triangles and saying, okay, how does 10 compare to 25? And I could set up a ratio and I could solve for these two sides. We'll call it y and we'll call it z. And I could solve for those two sides using my proportions as we've been doing before. Now you'll notice that the ratios between these sides on these triangles are going to be the same. If we actually set up the proportions and were to figure these out, right, I'd say, okay, let's set up the whole proportion. We'll say, looking at the other triangle here, let's compare 8 on my triangle on the left to y on my triangle on the right. Let's compare 10 on my triangle on the left to 25 on my triangle on the right. And let's compare 6 on my triangle on the left to z on my triangle on the right. Now I can use 2 at a time to solve for these sides, as we've been doing. And if you do that, you'll find out that side y is 20 and side z is 15. Now let's do a little comparison of the ratios as we did at the start of this lesson. Okay, so let's compare the ratios of our sides. On our first triangle, let's look from our 30-degree angle, and let's compare the opposite and the adjacent sides. So I'm going to say 8 divided by 6. Let's compare that to our triangle on the right. Our opposite and our adjacent sides is going to be 20 over 15. And if you actually compare those two, those are equal to one another. So we say even though the sides are not the same because they're similar triangles, those proportions are equal to one another. We can do some other comparisons. Triangle on the left, we can compare the opposite side to that 30-degree angle and the hypotenuse. That would be 8 over 10. And we realize that that's equal to, on the other triangle, our sides of 20, the opposite side to that 30-degree angle, over 25. And we realize that our last comparison, our adjacent side on our smaller triangle to our hypotenuse, is equal to our adjacent side over our hypotenuse on the big triangle. Okay, so all of our ratios dividing those sides are going to be equal to one another, even though the triangles are different sizes. Okay, now I'm going to hang a little bit of language on this. There's some terms we got to get used to. So here we go. We call these three things the primary trigonometric ratios. You're going to see these three things on your calculator. You're going to see a thing that says, it looks like it says sin. We pronounce it sine, because the full thing is like this, sine with an E. The next one you're going to see on your calculator is cosine, but it's just spelled cos. And the third one you're going to see is tangent, just as tan on your calculator. So we're going to be making use of those buttons on your calculator. These are just names that the ratios are given. Basically what each of these means is take two specific sides on the triangle and divide them to see what that ratio works out to be. Okay, take two specific sides and divide them. So when we see the word sine, what that specifically means is sine of some angle, looking from that angle theta. In our previous example it was 30 degrees, right? But looking from that angle, take the opposite side and divide it by the hypotenuse. So that's all sine means. It means take the opposite side and divide it by the hypotenuse. And sine just happens to be the name that was given mathematically. Now when you take the adjacent side and divide it by the hypotenuse, that was given the name cosine. So cosine of that angle means you look at that angle, you figure out your adjacent side and your hypotenuse, and you divide them by one another. Tangent is just the name, meaning take the opposite side from your angle and the adjacent side to your angle and divide them by one another. So each of these are going to make three different ratios, and those ratios would be the same on any similar triangle. So any similar triangle, we're going to end up with the same thing. Now there is a little short form. I'm going to want you to write this down for sine, cos, and tan to make it easier to remember so you don't have to write this out every time. And this is how it goes. It goes so, ka, toa. And so I would recommend whenever you're starting to work with trigonometry, write this right at the top of your page. And write this on your learning goal sheet as well so you have it handy. So ka, toa. Sine means opposite divided by hypotenuse. Cosine means adjacent divided by hypotenuse. Tangent means opposite divided by adjacent. So this is a brief little mnemonic to help us remember what those things mean. Sine, cos, and tan. Even though I've been teaching math for a long, long time, I still use SOHCAHTOA to remind me what each of those mean. So SOHCAHTOA is something you're going to want to remember. Okay, so let's have a look at an example. We're going to try and write down some of these ratios. What does the sine ratio look like? What does the cosine ratio look like? What does the tangent ratio look like for this triangle that we've got right here? Okay, so the first thing we need to do is we need to consider what angle we're going to look from. So first, let's assume we're going to look from this angle. Let me get a smaller pen here. This angle right here. Okay, I'm going to call it theta. That's the angle we're going to look from. So I want to label the sides of my triangle. So I'm first going to look and see where my hypotenuse is. That's always a great place to start. This is my hypotenuse right here. Right across the triangle on the other side, that's my opposite side. And right next to my angle, this is my adjacent side. Okay, so I've labeled them. Now I want to, for part A, write down the ratio for tan x, sine x, and cos x. Oh, sorry, I should have called, oops, we were looking at angle x, so I'm going to switch that around. Just so I'm making sure we're doing this in the right order. Here we go. Okay. So you might have your triangle labeled. That's no problem because we're going to do the other side too. So again, this is our hypotenuse. That doesn't change. I'm looking for angle x right up here. My opposite side is over here. It's 15, and my adjacent side is right here. It's 20. So we're actually going to do both of the angles. So if you already drew on your notes, that's totally fine. Okay, so let's start by doing tan of angle x. Tan of x. Well, tangent is right here. It's the opposite side divided by the adjacent side. So the opposite side is 15, and the adjacent side is 20. So tangent of angle x we write as 15 over 20. Now I could divide those two numbers and get it as a decimal. That's fine, and there are times you may want to do that. For now, I'm just going to leave it as a ratio like this. Okay, let's do the other ones. Let's go sine of x. Sine is opposite over hypotenuse. The opposite side is 15. The hypotenuse is 25. finally I've got cosine of x. Cosine is adjacent over hypotenuse. The adjacent is 20. The hypotenuse is 25. Okay, let's change colors here. Now I'm going to look from angle y. My hypotenuse is going to actually be the same, but my opposite and my adjacent sides are going to switch. So this is now going to be my opposite side because it's opposite angle y. And my adjacent side is going to be right here because it is adjacent to angle y. So let's figure that out. We're going to do tangent of angle y, sine of angle y, and cos of angle y. So tangent, again, is opposite over adjacent. The opposite side is 20. The adjacent side is 15. Sine is opposite over hypotenuse. So the opposite side is 20. The hypotenuse is 25. Cosine is adjacent over hypotenuse. So the adjacent side from angle y is 15. The hypotenuse is 25. You might notice some relationships here. You might notice that between tangent x and tangent y, the ratios have just flipped, right? And that's because our opposite and adjacent sides are switched. And you might notice that what was sine x is now cos y, and what was cos x is now sine y. So the sine and cos ratios have flipped. And that's because they have the hypotenuse, which hasn't changed, but whether you're looking at opposite or adjacent sides have switched. Okay. Now, if I had both, if I was looking for either angle, I could use any of these ratios, and they would all work, and they would all give me the same answer. So when I'm doing math with trigonometry, sometimes there are multiple ratios that will give me the right answer, and I can choose any of them. So different students might choose different ways to do the same sort of problem. Okay, now this is a lot of talking about these ratios. Let's try and put them to work a little bit, and let's get those calculators ready. So I'll ask you please to grab your calculator and haul it out, and you're going to look for the sine, cos, and tan buttons. The first thing we're going to look at is with those sine, cos, and tan buttons is we got to look on the screen of our calculator and see if our calculator is in degree mode or if it's in radian mode. You probably don't know what a radian is, and that's okay. You won't know until much later in your math education. For now, we're using degrees. So you may have the word degree or radian. You may have DEG on your calculator screen and R or RAD, or you may just have a D or an R. We need to make sure that we are in degree mode. And so if you're in radian mode, you're going to need to figure out how to switch that. I can help you with that, but each calculator is different. So that's kind of tricky. So that's something I'll just ask you to be aware of, that we need to be in degree mode, and each calculator switching it out is a little bit different. So you may have to mess around with your mode, and so get some help if you want to change your mode into degree mode, but we're going to need that, okay? So eventually when you start doing these problems, you're going to need it in degree mode. We're going to try it right now, and if you're not in degree mode, you'll notice that your answers are different from mine, okay? So here we go. Let's try this out. The first thing we're going to do is we're going to do sine of 36. Now, the best calculators that are two-line calculators, you can type it in just like you see here. You can type in sine, and probably your calculator will throw a bracket in there, so you'll hit the sine button and it'll go like this, like that, and then you can type in the number 36, close the bracket, and hit your equal sign and see what you get. If you're using a calculator on an iPhone, which will be bad for this stuff, like very bad, or if you're using certain types of calculators, you'll actually have to type in the 36 first, and then you're going to hit the button, the sine button on your calculator. Okay, so you're going to have to experiment with this and see what will give you the answer we're looking for. For the calculator I'm using, and for what the calculator for most of you, if you're using a scientific calculator, you'll type it in as you see it. So if we are in degree mode and we type in sine, and then 36 degrees, and we hit equals, we're going to get a big long decimal number. Okay, so this one is going to equal 0.58, and I'm going to round off to 4 decimal places here, 7, 8. We usually round off with these ratios. We round off to 4 decimal places. So basically what we're saying here is, if we've got a triangle, and it has an angle of 36 degrees, we know sine is the opposite side divided by the hypotenuse. If you take any triangle at all, any triangle that's a right angle and has an angle of 36 degrees, and we take the opposite side from that 36 degrees and the hypotenuse and we divide them, we're going to get this decimal number if we divide those two sides. No matter which triangle, no matter the size, as long as it's got 36-degree angle and it's a right angle triangle, we'll get that number for any 36-degree angle triangle, okay, because they would be all similar, right? So that's what we got for our first one. I'd like you to try and do the ratio for the next two. I'm going to write it out, and I'd like you to try it in your calculator to make sure you can get these same answers. So our next one is tangent of 78 degrees. And when you plug that into your calculator, you're going to get 4.7046 if we round it off to 4 decimal places. And finally, cosine of 12 degrees, you're going to get 0.9781. Okay, so I'd like you to make sure you can use your calculator to get those ratios. So again, these are ratios. These are two sides of the triangle divided by one another, and that's the number we get when we do that dividing. So for our first one, it was opposite side over hypotenuse. For tangent, it's opposite over adjacent sides when we're looking from the 78-degree angle. And for cosine, it's adjacent over hypotenuse sides when we're looking from the 12-degree angle. Okay, and that's the ratio we get when we divide those two sides. Okay, next what we're going to do is we're going to take a ratio and we're going to convert that ratio into an angle. So basically what I'm saying is, I know that I've got a triangle that when I divide, cosine is adjacent over hypotenuse, right? So when I divide the adjacent and a hypotenuse sides, I get a ratio of 0.866. But what's the angle of triangle that gives me that? Well, here's how to do it. Okay, you're going to need to look for the second function button on your calculator. That's going to look like this, probably second, or it might look like shift. It might have the word shift. It's usually up in the upper left-hand corner of your calculator. Okay, you're going to need to hit that button first, and then you're going to hit your cosine button. And what should appear on your screen when you do that is it'll say cosine with a little -1 on it. So it'll look like this. It'll give you a thing that says cosine -1, and it might have an opening bracket to it as well. Okay, this is how we're going to undo that ratio to figure out what angle it's associated with. So this is basically the reverse of what we just did. So try that on your calculator, see if you can use the second function and then the cosine button to get this. And so here's what you'll actually type in, you'll actually write and what you'll type in. So you're going to say x is going to be equal to the cosine inverse, and we'll use that second function or shift button, and then hit my cosine button. And you'll probably see cosine to the -1 written above your cosine button on your calculator. And that's going to be equal to 0.866. And then I'm just going to hit enter on my calculator, and I'm going to see what I get. Now I should get a angle here. So 0.866. I plug that into my calculator, and what I end up getting is 30, we'll round off to 1 decimal place, 30.0 degrees. So what I've got is an angle in degrees. What it's telling me is that in a 30-degree angle triangle, when I divide the adjacent side by the hypotenuse, I'm going to get a ratio of 0.866, no matter how big or small that particular triangle happens to be. Okay, let's try another one. We're going to need to use that shift button and hit the sine inverse this time to see what our angle A is. So we're using this to find an angle, so I'm going to go sine inverse. 0.2345, and I'm going to see what I get. Looks like I'm going to get 13.6 degrees when I round it off to one decimal place. 13.6 degrees. Okay? So this is how we find an unknown angle when we know the ratio of two sides that have been divided. So we might have to know the sides, or we might just happen to know the ratio of those two sides. Okay, so that's finding an angle. Let's actually take this to some triangles and try and apply this and figure out the sides of some triangles. Getting on 30 minutes here in the lesson, so I'm going to speed this up a little bit so you can do a little bit less of listening to me talk and a little more doing. So here we go. SOHCAHTOA is up here at the top, which is really nice because that's going to allow us to remember that. And now we're going to do some solving. So first thing I'm doing is I'm looking from my 72-degree angle, right? So let's label my sides. This is my hypotenuse, this is my opposite side, and this is my adjacent side when I'm looking from that 72-degree angle. Now, there's a couple of sides I'm interested in. I'm actually going to erase adjacent because it turns out that's not one that I'm interested in. I know my hypotenuse, it's 36, so that's useful. And I want to know my opposite side, so that's useful. The adjacent side, I don't know and I don't care about it. So I'm actually just going to leave that off here. And I'm going to say to myself, okay, which ratio involves the opposite and the hypotenuse? Turns out that that's sine ratio. Sine ratio wants opposite and hypotenuse. So I'll write this out as sine of angle 72 degrees is going to be equal to my opposite side, that's x, over my hypotenuse, that's 36. Now I could punch sine of 72 into my calculator and get it as a decimal number, because that's all one thing, right? That's just a decimal number. But I don't want to do that because that's going to leave me with a big long string of decimals, and I kind of want to just keep this exact for now. So we're going to do our cross multiply game. I can actually imagine this is over 1. And so I'm going to say, okay, 1 times x is x, and 36 times sine of 72 is 36 sine of 72. And I can actually write those together. Now this is just two things. This is the number 36, and this is sine of 72 degrees, which is just a decimal number itself. It's just a ratio itself, okay? So now I'm going to multiply those two things together. You could work out what that ratio is, but I just want to plug this into my calculator in one go. 36 times sine of 72 degrees, and you should get an answer of 34.2. That's the side length x on my triangle that I'm looking for. Okay, let's move to my next one. This one I also want to find a side. It's the hypotenuse on this triangle. So if I'm looking for my 40-degree angle, I know, of course, that's my hypotenuse. Let's switch pens here. Let's go to green. That's my hypotenuse. And the side right next to my angle here is my adjacent angle. So I'm not going to be using sine anymore because the sides of the triangle I've got are the adjacent and the hypotenuse. So let's look up here. What's adjacent and hypotenuse? It's cosine. So we're going to use my cosine ratio. So I'm going to say, okay, cosine of 40 degrees is going to be equal to my adjacent side, that's 48, over my hypotenuse, that's my unknown. Now let's do my cross multiply game. This is over 1. So 1 times 48 is 48. And x times cos of 40 is x cos 40 degrees. Now I want x by itself. So how am I going to do that? I'm going to divide both sides by cosine of 40. Again, that's not two pieces, that's one thing. Cosine of 40 is one thing. It's actually going to work out as a ratio if you plug it into your calculator. So I'll divide both sides by cos 40, and I'll end up with x equals 48 over cos 40. And now I'm going to plug that into my calculator and see what I get. 48 divided by the cosine of 40 is going to be 62.7. That's the length of my hypotenuse. course, I always ask for a nice box around the answers, so why don't we do that to have a nice box around my final answer. There. Okay, now we could find sides of triangles using trigonometry. We can also find angles. So I'm going to show you how to find an angle right now. Okay? We did it before when we were practicing using that inverse function on our calculator. Now we're going to use it using a real triangle. So here's the angle I want to find. It's called x. I'm going to label this is my hypotenuse and my adjacent side. So hypotenuse and adjacent, that's cosine. That's like the one we just did. That's going to be a cosine ratio. So I'll say the cosine of my angle x is going to be my adjacent side, that's 12, over my hypotenuse, that's 24. Now I could divide those and I know that's going to be equal 0.5, right? That's a nice number that it turns out to be. But it actually is nicer in your calculator if you don't have to divide these. You can just plug them right into your calculator. So that's actually what I'm going to do. I'm going to hit Shift and the cosine button to get the cosine inverse. Should look like that. And then in my calculator, I can actually type in 12 divided by 24. It'll look kind of like that in your calculator. And that'll save me some steps if I just type it directly into my calculator like that. So it is 0.5, but I'm going to leave it in there because in more difficult problems, it'll work out more nicely. And that should give me an answer of 60 degrees. Okay, let's try one more here. Actually, these last two, D and E on your sheet, you can pause the video and give them a try right now. Okay, try setting up your ratio for D and E. Let's pause the video and give it a try right now. Okay, so you've paused your video, you've given these a try. I'm going to jump in and do these kind of quick now that you've had a look at them. My angle is 31. This is my opposite side. This is my adjacent side. My hypotenuse I don't care about. Opposite over adjacent, that's tangent. So my opposite side is x, my adjacent side is 12. Do my cross multiply game. 1 times x is x. 12 times tan of 31. Multiply those together and I get 7.2 if I round it off to 1 decimal place. My last one, E, you've had a look at this already. You're finding an angle. This is my adjacent side and this is my hypotenuse. So adjacent and hypotenuse, that's cosine. So cosine of my unknown angle is my adjacent side over my hypotenuse. So x is going to be the cosine inverse of 11 over 19. And that's going to give me an angle 54.6 degrees. Well, I'm not being very consistent about putting a box around my final answer. Oh, the marker is getting away from me there. Let's get rid of that. All right, put a box around my final answer. Okay, so now you've got a little bit of stuff to work on. Again, this looks like a lot, but these questions, the first ones are actually pretty short. A lot of them are just labeling things. And then the later ones are questions that are going to be a little bit more challenging. We're going to spend several days working through these things and trying problems and trying more challenging situations. So I know this is a lot to figure out at first, but this is a concept we're going to use quite a bit and we're going to build on. Okay, so our goal is to build that comfort level over the next few days. Go for it. Good luck.